Hey Chemistry fam, we are back and going to be working on Stoichiometry worksheet 1, 2, and 3 steps. Now we've been doing stoichiometry and we've been focusing on 3 steps, but sometimes you don't do exactly 3 steps. Sometimes it's only going to be 2. But to do that, we're still going to use our mole map, but occasionally maybe you'll start with mass of one object and only need to solve for the moles of another. In that case, that would be a 1, 2-step problem, instead of a 3 like we've been doing where we maybe go back to mass of another object. So with that being said, as long as you know where you start and where you end, you will know how many steps to take. So let's go ahead and do that. All right, problem number 1 says that if you have 4.23 liters of barium chloride and it reacts with excess silver phosphate, that's fine. It's going to react with excess silver phosphate, but that doesn't say anything or do anything really for the problem. We want to know how many formula units of silver chloride will be produced. So that means it looks like I have 4.23 liters of barium chloride, and I'm going to want to convert it into formula units of silver chloride, which is AgCl. Notice, since this is 2 different compounds, barium chloride and silver chloride, that means we have a compound A and a compound B. If we were going to go from barium chloride and stay with barium chloride, just find, like its mass instead of liters, then we'd be staying on the A side of the map. But in this case, it looks like we're starting with volume of A, because we're in liters of the A subject. And we're going to end up with formula units of object B, which means that would be under the particle island. So that looks like we're going to take a 1, 2, 3 steps there to do that. Okay, awesome. And you have your mole map. You can follow along. But let's get down to business and work this out. Now, first of all, we do have to balance our equation. Don't forget about that. I've got 3 bariums on the right side. So if I put 3 here, that's 3 bariums, but that makes 6 chlorine. So I need to put a 6 here, but that makes 6 silver. So I have to put a 2 here, but that makes 2 PO4s or phosphates. Ooh, but I already have a 2 over here, so we're good. I think that's going to be a 3, 2, 6, 1. Feel free to pause it, balance it out, and make sure you understand, but I'm assuming you know how to balance. So with that being said, we always start with our A object, and remember, our A object is always the thing that we have a number for. Since we're converting, we do have to have a number. All right? So this is going to be a 3-step problem. So I'm going to get my 3 steps ready. Step 1 is to go from volume A to mass of A. To do that, when you're headed downwards, you are going to divide by 22.4 liters on the bottom, and that is of object A, which is BaCl2. And that's for every 1 mole of BaCl2. All right? Now that we've gone there, we're going to go from moles of A to moles of B. And on your mole map, it says to put B moles over A moles. So since our B object is AgCl, that is going to go on top. And since our A moles is right here, that's BaCl2, that will go on the bottom. Now the number that we'll use is from the periodic table. So since we're dealing with B first, that's AgCl, that's the number up here, 6. So I'm going to say there's 6 moles of silver chloride for every A object, which is BaCl2, which is 3. So I'm going to do that. Let me erase this A so I have room to write. But I'm going to put a 3 there, 3 moles. Again, B is always on top, A is always on the bottom. For the mole-to-mole ratio, we're just using our balanced equation. That's why we have balanced equations, right? Last step, we are going to go from moles of B over to particles of B. To do that, it's simple. It says to multiply by Avogadro's number, 6.02 times 10 to the 23rd for every 1 mole, and that is all still of BaCl2. All right, let me double check my work to make sure my mole map did it right. Liters of BaCl2 cancel. Moles of BaCl2 cancel. Moles of AgCl2 cancel. Oh, and that is an error on my part. I wrote this as BaCl2. My apologies, but that should be AgCl. That is my fault. See, good thing I checked that. Remember, after BaCl2 is gone, you're left with AgCl after that point. So common error, common mistake, and you can see I made that too, but fix that up. All right, so we multiply that out, everything by the top, multiply, everything by the bottom, divide, and when we get our answer, you should end up with about 2.27 times 10 to the 23rd, and that is of formula units of AgCl. All right, if you're not getting that number or close to it, check with your calculator, make sure you are putting it in correctly. But otherwise, you should be getting right around there, 2.2 something times 10 to the 23rd. All right, so that was problem 1. All right, going to problem 2 now. We already have our balanced equation, so you can see that's right up here. I just brought it down, but we already balanced it. So let's see what we have. If we have 6.5 moles of silver chloride, that's AgCl, okay, that looks like our given, and we have a number for it, so that's probably going to be our A compound. If that's produced, then how many grams of barium chloride must have reacted? So if we ended up with that many moles of silver chloride, we want to know how many grams of barium chloride must have reacted in the beginning, all right? Since AgCl and BaCl2 are two different compounds, this looks like an A and a B relationship. Now I'm starting with moles of A, so that's where I'm going to begin on my mole map, and I want to end with grams of B, which is mass of B, so I'm going to end on this side. This ends up being a two-step problem, which is nice, less work. So let's do that. I'm going to take my number, 6.5 moles of AgCl, and I'm going to get ready for my 2 steps. Step number 1 is to go from moles of A to moles of B. To do that, we know it's B moles over A moles. Well, object B on top is BaCl2, right? I even defined it as that. Object A on the bottom is silver chloride, AgCl. See, I defined that up top. Now, where do I get my numbers from for the mole-to-mole ratio? Up at the balanced equation. BaCl2 has a 3 associated with it, so I'm going to say there's 3 moles of barium chloride for every, and look at AgCl, there's a 6, for every 6 moles of silver chloride. All right, good. Now that I have that, I'm at moles of B, and I need to get to mass of B. To do that, according to my mole map, I'm going to put 1 mole of the substance on the bottom. Now remember, I'm in BaCl2 now. I made that mistake in part 1. I won't make it again, though. And on top, I need the molar mass of barium chloride, which means I'm going to take the mass off the periodic table. So 1 barium plus 2 chlorines, I end up getting about 208.23 grams. All right, double check your work. Do moles of AgCl cancel out? Yes. Do moles of BaCl2 cancel out? Yes. Are you left with grams, which is what you're solving for? Yes. So we are good. Multiply everything by the top, divide by everything on the bottom, and you should end up getting about 676.75 grams of barium chloride. There we go. That ended up being a 2-step problem instead of a 3-step problem, but hope that made sense. If we jump to number 3 here, it says how many molecules of silver phosphate, so that looks like something I'm going to need to solve for, reacts with this many formula units of barium chloride. All right, so what do I know I have? I have 5.05 times 10 to the 24th formula units of barium chloride. That's BaCl2. What I need to find is how many molecules, so MCs, molecules, of silver phosphate. And when I look up at my balanced equation, silver phosphate is Ag3PO4. All right, are these two different compounds, BaCl2 and Ag3PO4? Yes, so that means my starting one with the number is my compound A, and what I'm solving for is compound B. Starting at formula units of A means I'm going to start here on my mole map, and ending with molecules of B means I am going to end up at particles of B, which means I'm going to do a 1, 2, 3-step problem. All right. Done it before, and I can do it again. Let's rock it. Start with what you have. You have to start with a number for conversion. So 5.05 times 10 to the 24th 4 millunits of barium chloride. Step 1, step 2, step 3. Okay, step 1 is to go from particles of A to moles of A. To do that, it's simple. I am going to divide by Avogadro's number, so 6.02 times 10 to the 23rd, and that's 4 millunits of barium chloride. And up on top is going to be for every 1 mole of barium chloride. Great. Now that I'm in moles of A, I want to get to moles of B. To do that, I'm going to do my B moles over A moles. My B object is Ag3PO4, or silver phosphate, and my A compound is barium chloride, BaCl2. Now, up at the balanced equation, there are 2 moles of Ag3PO4, or silver phosphate, for every 3 moles of barium chloride. Perfect. Now that I'm in moles of B, I'm going to go to particles of B. To do that, I'm going to take 1 mole of my substance, which is silver phosphate, and I say for every 1 mole of that, it's Avogadro's number, 6.02 times 10 to the 23rd. Technically, I ran out of room, but I should write molecules of, or not molecules, sorry. It says molecules of silver phosphate, but technically that's a little bit of an error. That should be formula units, since silver phosphate is an ionic compound. But we're looking for particles, so the math still stays the same. But we've got formula units of barium chloride, moles of barium chloride, moles of silver phosphate, cancel out, and we're left with our formula units or molecules of silver phosphate. Technically, it should be formula units, though. That is a typo in the question. So we're looking for formula units of Ag3PO4. If I multiply everything on top and divide by everything on the bottom, I should end up getting about 3.36 times 10 to the 24th formula units of silver phosphate. And again, I know I asked for molecules, but technically silver phosphate is an ionic compound, so that should be called formula units. Regardless, though, the number should stay the same, 3.36 times 10 to the 24th. All right, question number 4 says, if 45.7 grams of silver chloride were produced, so I already have a number, that's great, so I bet that's going to be my A. How many moles of silver phosphate must have reacted? So I want to convert that to figure out how many moles of silver phosphate, Ag3PO4. Okay, since this is 2 different compounds, this is going to be my B compound because it's what I'm solving for. All right, so I'm starting in grams of A, which is mass of A, and I want to end in moles of a new substance, so that's moles of B. So this is going to be a quick 2-step problem. All right, let's rock it. 45.7 grams of silver chloride is right there. I'm going to have a 2-step problem. Perfect. To get rid of mass and go to mole island, I need to divide by the molar mass and multiply by 1 mole of it up on top. All right. If I add up silver plus chlorine off the periodic table, I end up getting a mass of about 143.32 grams. Great. Now that I'm in moles of B, because I converted, I went from mass of A to moles of A. Now I need to go from moles of A to moles of B. To do that, we put B on top, A on the bottom. All right, A is silver chloride, so I'm going to put that on the bottom, and B is silver phosphate, so I'm going to put that on top. Now, you should be remembering by now, where do we get these numbers for mole-to-mole ratios? Up from the balanced equation. So I know that there are 6 moles for every silver chloride, and there would be then 2 moles for every silver phosphate. But there you have it. Multiply by the top, divide by the bottom, all my units cancel out, and what I end up getting for number 4 is about 0.11 moles of silver phosphate, Ag3PO4. Okay? That ended up being a 2-stepper, not too bad. Well, we're on our last two from the front page. This is number 5. And we have an 85 grams of silver chloride, okay? So right off the bat, that is given to me. So that looks like that is my A substance, all right? And I'm going to figure out what the mass of barium phosphate is, according to the reading, which is Ba3PO4 2. So this looks like I'm going to go from mass of A to mass of B. I can do that. Follow the chart. Okay, since it's going to be from mass of A to mass of B, this is going to be a 3-step problem, but we've done this many times before. So let's get to it. 1, 2, 3. All right, first, if I want to go from mass of A to moles of A, I need to divide by the molar mass of silver chloride for every 1 mole of silver chloride according to my map. If I look on the periodic table, silver chloride's mass is going to be about 143.32 grams. We figured that out in the last problem, so you really didn't need to recalculate that. Now that this will cancel out our grams of AgCl, we now are ready to go from mole to mole. Remember, B moles on top, A moles on the bottom. My A substance is silver chloride. My B substance is barium phosphate. All right, I look up on my periodic table. There's 1 barium phosphate for every 6 moles of silver chloride. So there's going to be 6 moles for every 1 mole. And again, I use my balanced equation to figure that out. Moles of AgCl cancel out. Excellent. I'm left in barium phosphate moles, and I need to get to mass. To do that, I need to take 1 mole of the substance, which is barium phosphate. That goes on the bottom. The reason it does is moles are going to cancel out, right? But on top, I need the grams of barium phosphate, Ba3PO4. Ooh, I'm sneaking it in. There's a 2 in there. All right, if I add all of them up, right, on the periodic table, there's 8 oxygen, 2 phosphorus, and 3 barium. So that's quite a few to add up. But if you add them all up, it comes out to about 601.93 grams. So 601.93 grams. Sorry, I'm kind of cramming it in there. But if you end up doing that with all of your math, multiply by the top, divide by the bottom, the number you end up getting for mass ends up being about 59.5 grams of what? Of barium phosphate, which is Ba3PO4 2. All right? Hopefully we're flowing through this, and it's becoming much more natural, which is the goal. All right, let's do our last example, number 6. We want to know what the mass of silver phosphate is that reacts with 20.56 liters of barium chloride. Okay? So if I have 20.56 liters of barium chloride, and I want to know what the mass is of the silver phosphate, Ag3PO4. Okay? That means I have barium chloride is my starting compound, and silver phosphate is my ending compound. If I'm going to start with liters of A, that's going to be in volume, and if I'm going to end in mass of B, that's going to be grams of B, which is going to get me 1, 2, 3 steps. All right, let's do it. If I start with 20.56 liters of barium chloride, I'm going to need 3 steps to get this done. And I'm going to be strapped for space, I bet, so I'll try to cram it all in there. First of all, to go from volume to moles, I am going to put 22.4 liters for every 1 mole of barium chloride. Okay. Now that I've gotten into moles of A, I need to go to moles of B. To do that, we always do B over A moles. My A substance is still barium chloride, and my B substance is silver phosphate. If I look up at the top, barium chloride has a 3 in the balanced equation. That means there's 3 moles of barium chloride for every 2 moles of silver phosphate. And again, we use the balanced equation to do that. Now that I'm in moles of B, I'm going to go to mass of B, which means I'm going to have to put 1 mole of silver phosphate on the bottom, and I'm going to put grams, the molar mass of silver phosphate up top, which if you add up 3 silvers, 1 phosphorus, and 4 oxygens, you end up with about 418.58 grams. If I double check my work, liters of barium chloride cancel, moles of barium chloride cancel, moles of silver phosphate cancel, and I'm left with grams of silver phosphate. Multiply everything on top, divide by everything on the bottom, and I end up getting about 256.13 grams of silver phosphate. Right? As long as you know where you're beginning and where you're ending and you use your mole map, this should be straightforward to you. And once we quiz on this, that's what you'll be expected to do, to use your mole map and to show your work to eventually get us the right answer. All right? Thanks for stopping by, Chem Fam. Much love. See you soon.